First, let's go through the hardware that you need for the probe model calibration. You need a computer with slicer running on it. Then you need the Sonics Touch with the GPS extension. And then what we are going to use today is the L14 probe. And since I want to use the standard configuration that comes in the Plasset package, I'm going to use a separate reference sensor, and the stylus. In this case, it's the vascular needle from ultrasonics with the 0.9mm sensor. It has a better range of operation than the 0.55mm sensor for the nerve block needle. So, slicer is already running. What we are going to compute is the probe model to probe transform. So we are going to load the CAD model of this probe. File, add data, add files. Then you select the model of the probe, open, apply. And then you have this model, which is an older version of this probe, but it still has the same handle part. This bottom part is not the same, not exactly the same, but we are not going to use that for the registration now. What is important in these probes is that they have a marker which identifies the marked side of the probe. It can be, you can always feel it with your finger, and you can find this mark on the probe, on the Model 2. So this is important to have the same side, otherwise it's symmetric. So since we are using landmark registration, first we are going to define the landmarks on the model. So I'm going to fiducials module in Slicer. I'm creating a new fiducial list, and I'm going to name it model fiducials. And as a minimum you have to use 3 points for landmark registration. Now we are going to use 5. If you use more, then there is a less chance of error. So I'm going to start from the mark, and it's important to select points that it will be easy to identify on the physical model. So the intersection of these plastic parts is good. That's our first point. Second point is up there. Third point is on the other side. Here. Fourth point is just the opposite of the first. And just to have one point out of plane, I'm going to put a point here, which is again easy to identify the physical probe. So we have 5 model points. I now create a new fiducial list, and I will name it probe fiducials. The probe is the standard naming, and the standard name in plus is the coordinate system of the sensor in the probe. So to define the probe fiducials, we will use the needle as a pointing device. So let's create an OpenIGT-Link connection in Slicer in the OpenIGT-Link IF module. So add server active is always the standard that we use. And then, before we use the pointing device, I want to make sure that the stylus tip to stylus, so the pivot calibration is correct. So we are going to run that now quickly. So I'm opening FCal. And before I connect to the devices, let's make sure that they are plugged in the correct order. The device set description says that from the left to right, the tools should be plugged in as probe reference stylus. So the probe is obviously this one. Yeah, come here and have a look at the plugs. So the leftmost is probe, the second one is the reference, which is just this, and then the stylus is the needle. Okay? And then I connect to the devices. It takes about 30 seconds to connect. And you don't need the FCAL Phantom for this whole procedure, but I just want to fix my reference sensor to something, and it's just handy to use this. So you have the needle as a pointing device, and we'll just compute the stylus tip to stylus transform. So the devices are connected. I go to stylus calibration. Since this is a short stylus, I just need 50 points. And I'm just going to use this foot pedal for mouse clicks. You can use your friend or buy a pedal yourself, and then you can do this alone. So you just have to make sure that the needle tip will not move respective to the reference. Then start this pivot calibration. And as you see, points are collected on a sphere surface, and then the pivot point will be computed as the center of the surface. Okay, it's done. My error is 0.44 millimeters, which is good, I accept that. And we have the stylus tip to stylus translation displayed, but we're going to save this config file with the stylus calibration. So I'm just going to give the device set a name. For now it will be pivot calibration, and save the file. The file name will be model registration demo. Save. So we don't need FCAL anymore, so we can close it. But there is one more thing that we need in that config file. So I'm opening that config file, model registration demo, and I'll just go down to the open IGTailing part. It's here. So since we are doing a special registration now, what we need to be sent to Slicer is the stylus tip to probe transform. To probe. Because with the stylus tip we will touch those points on the model surface. So that's how we are going to compute the model to probe transform. Okay, and we have to identify the IP address of the machine, Slicer. So you can do it with IP config. Okay, so it's 130. Seven, 125. Of course, if you're doing a lot of stuff with Plus and Slicer, you probably already have a config file with this IP address. So, but now I'm just doing it to make it complete. So, to make it consistent, I'm going to copy this IP address to the image destination 2. I'm going to send everything to the same computer. Okay, so I have my config file now. Now, the next program we will need from the touch running is the OpenIGT broadcaster. OpenIGT broadcaster. If you just start it without any command line arguments, it will present a help. Input config file equals, and then we need this config file that we have just created. Okay. So I'm just running the broadcaster. I don't need my reference transform now since I'm not sending that to slicer. What I will use is the probe and the stylus. Those two guys. Okay, as you see, OpenIGT broadcaster has a little GUI, which will come in very handy now. I just hover my mouse over pause, so with the foot pedal I can always stop the sending of transforms, which is very good if you are alone and you don't have free hands. So I'm going to go to the data module. I already see that stylus tip appeared in Slicer because we are tracking it. It would be good to see it. So in the IGT tool selector module, I put a default tool on the stylus tip. So it will be somewhere in the C. And then I'm going to the collect fiducials module, and I'm going to collect stylus tip points. They are going to go to the probe fiducials, and we need 5 of them altogether. Initialize points. So when I press the get new measure button, it will just record that position. So to make sure that we are going in the same order, it's going to display these fiducial names. This so I can see it. And all I have to do is find the same points that I have defined on my model. Find the same points with the needle tip. So this is my first point. I'm going to stop broadcasting with the foot pedal and then press the get new measure button here to capture this position. Okay, second point. You remember this was the one. Okay, so play and pause. Get new measure. Okay, play on the other side, on the top. Pause and get new measure. And then play, pause, get new measure, and then the last point. It's here. Pause and get new measure. At this point, we have recorded these points, but we still have to click Save Fiducials. And you just have to make sure that the points look like they are from the same configuration as the red points. For some reason these points are not selected, so I have to go to the Fiducials module and just select all of these points to take them into account in registration. So I go to Registration, Fiducial Registration, and then Fixed Landmarks. So we are computing model to probe transform, so the fixed landmarks are the probe fiducials. The moving points are of course the model fiducials, and we are going to save this transform in a new transform that will be created by this module. It's a rigid transform because the STL model was in millimeters and we are tracking in millimeters, so we don't need similarity. Apply, it says completed, so the transform is already ours to use. It's here, fiducial registration transform. And to make sure that the registration is went well, we are just drag and drop the model fiducials on top of the fiducial registration transform. As you see, the fiducial the fiducial list was transformed, and if you go closer, zoom in well, then you can see that there are 2 fiducial points in every position. That's because the model fiducials were transformed to the pro fiducials. So they now line up well, and this shows us that the registration went with very little error. So we rely on this. So if we transform and drag and drop our probe model on top of this fiducial registration transform, and then we know that its position in the tracker space is already it's already the same as with the stylus. So if we play the broadcaster again, then if we touch these points with the stylus, then you can see in slicer that the stylus, when the stylus touches the surface of the physical probe, then that ball, which represents the tip of the needle, is always halfway into the probe model. Now if you look carefully, you can see that the orientation of the stylus is not the same in the model, in slicer, and in the physical space, but it doesn't matter. So we just use the stylus for picking points with the tip, so it's not really important what the orientation is. So we're not spending time on fixing the orientation of the stylus. Now you have the transform. If you go to the transforms module of slicer, then this fiducial registration transform here, as you can see, is the matrix that you were looking for. So this is the probe model to probe transform. And you can save it in slicer with the scene, or you can copy it to another file if you want to use it in another program. But basically that's it. We have computed the probe model to probe transform.